the topic of measurement, significant figures is something that is probably a new concept to you. However, it's key when we begin to look at measurements to understand a little bit more about what kind of information we're getting. Let's take a look at a couple of examples. Let's say we have a rock. The rock. Okay. And then we have another rock. The two rocks look somewhat similar in their size, and we'd like to determine if they actually have the same mass. Now, if we put it on balance number 1, balance number 1 says the blue rock is 100 grams, and the red rock is 100 grams. Now, if our balance can only read sorry about that. Now, if our balance can only read to a hundredths place, that means that it can't read any information here. So it could read 100 grams, and if it's between 100 and 200, it would either round it down to 100 or up to 200. And if it was less than 100, it would either round it up to 100 or down to 0. This particular balance doesn't give us a lot of information about the rocks. Let's say we get a better balance. Okay, when we put these two rocks on the better balance, we get a little bit more information because this measurement is a little bit more accurate. See, now we know that over here, this would only tell us to a hundredths place. This one can read to the tens place. It's what we call a more sensitive balance and therefore a more accurate balance. Okay, let's go to another balance. Okay, now look at this reading. This reading is more accurate than this reading. This reading goes all the way out to the ones place. Now we'll put it on, finally, a fourth balance. And lo and behold, on this fourth balance, which has even more sensitive, which means it's even more accurate, it gives us even more information, this balance is actually able to tell that there is a difference in mass between the blue rock and the red rock. Because this one can read to the tenths place. So when we're looking at how we measure something, the measurement also tells us something about the limitations of the instrument that actually took the measurement. Okay? For example, if we look at this measurement, we don't have a whole lot of information. This is not a sensitive balance. Okay? This balance, more sensitive, more information, closer and closer and more accurate. Okay, we get all the way down here, and now we can actually distinguish between the two. It's important for you to understand that the idea of what we call significant figures tell us about the accuracy and what we call the certainty of the numbers in a measurement. Now, some numbers in a measurement are not called significant figures. It doesn't mean that they're not important numbers, but they're not what we call significant. So for example, this number here, there's a lot of uncertainty here. There's uncertainty in this place and in this place, this place and this place. Okay, pretty certain that this is 1, okay? Might be 2, might be 0, okay? But lots and lots of uncertainty about what's here. Okay, so this is our most certain measurement right here. Here, we're very, very certain about this one now. Okay, this one has the most uncertainty, has some uncertainty, and this number here is like completely, totally uncertain what it is. This one we're pretty sure it's either maybe plus or minus 1. Okay, so this measurement is off. There's some uncertainty, maybe plus or minus 10. And this one, we're very certain about this one, and now we're certain about this one too. Okay, the most uncertainty is here in this last measurement, last figure. Now we get down to this balance. Now we're very, very certain about these. Okay? No uncertainty here, little bit of uncertainty here. So when we look at these numbers, they tell us about how accurate and how certain our numbers are. Usually the last, what we call significant figure, tells us the number that we're the least certain about. So our next question is, well, when we look at a measurement, how do we know which ones do we consider significant? So in other words, one is say which numbers are significant in a measurement and which ones are not. So first of all, all non-zero numbers are what we call significant. Anything that's not a zero gives us information about the accuracy and certainty in a particular measurement. The problem is when it gets to zeros. Remember in our previous example, when we looked at these, this one was the least uncertain number. Okay? These could have been way, way, way off. So there's almost no certainty in these numbers at all. This one we know it's either plus or minus 1 here. Okay, so it could be 0 something grams, or it could be like 200 grams. Here, this one and this one, these non-zero numbers, we're very certain about this one. This one has a little bit of uncertainty and lots of uncertainty here at the last place. So what it appears is that the problem appears to be in understanding about the zeros. So zeros come into two categories. Zeros are either placeholders, or they're significant. Now what do we mean by placeholder 0? These are placeholder zeros. Now, understand that the word significant, or saying something is not significant in a measurement, doesn't mean it's not important or has no value. For example, if I dropped these zeros off, just got rid of them, I would change the value of this measurement by a factor of 10. So they're important. However, only here is where we start getting some idea about this number is certain, this number has the most uncertainty. On the other hand, look at these two measurements here. If I put something on a balance and I say it's 0.2 grams, if I put it on a different balance and I say it's 0.20000 grams, Look at the difference between these two values. Okay? This measurement, even though it's at the 10th place, has some limitations. It doesn't go out any farther. So what are these numbers? No, not sure. They could be anything that would cause the computer inside our balance to round to 0.2. So we're not sure what these are at all. Now look at this measurement. Okay, we still got the 0.2, but now we have a whole bunch of zeros. Okay, all the way out to the 10,000th place. This would be a very, very, very super sensitive balance. Okay, this one says that there's something, we're very, very, very certain that these are all zeros. So now there's a whole bunch of certainty in this measurement compared to this measurement. Now these zeros on the end are called significant zeros. They're not placeholders. If we just got rid of them, essentially the value would not be any different. This just means it's 0.2 with a lot of certainty that there's nothing after the 0.2. Up to this point. Could be more after here. We don't know. Again, limitations. So zeros come into 3 categories. Zeros between other significant figures are also significant. We call these the sandwich zeros. What do we mean by that? Okay. This is a sandwich zero. The 4 and the 5 are automatically considered significant. This zero is in between the 4 and the 5, so it is also significant. So this is like bread, piece of meat, bread. Now look at this sandwich. This would be bread, bread, meat and cheese. It's still in the sandwich. So both of these zeros are considered significant because they're in between other significant figures. Okay? So that means that certain, 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 a little some uncertainty here. Now what if it's a big sandwich? Still a sandwich. Okay, this would be like meat, cheese, lettuce, tomato, more meat, more cheese. Big sandwich. All considered significant. Okay, certain, 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 certain. A little bit of uncertainty here. That's what the measurement tells us. That's what the significant figures tell us. Placeholder zeros are the ones that occur before the first non-zero number. For example, these right here are placeholders. These are not ever significant. Okay, they're important to the measurement. Okay, but here's where we have our first amount of certainties here. These are placeholder zeros. Now the last type of zeros are zeros that occur at the end of the number. These are significant if the number includes a decimal point. Okay, let's look at some examples of this. This number is considered a placeholder. This number is not significant. Okay. Certainty, some uncertainty, very uncertain. However, if there's a decimal point, this means certain, certain, some uncertainty here. Remember back to our example, okay? When we got to something that was becoming this sensitive, when we're starting to look at 10th place, 100th place, 1,000th place out there, okay? This means it's very, very certain that this is 98. Okay? We would round to 0.0, whatever's out here. Round to 0.0 versus 98. This has only two significant figures. Okay? That means the uncertainty is here. This means the uncertainty is here. That's important to remember. Okay, let's look at a couple of possibly confusing situations that are applications of this rule. Okay, what happens if the zeros at the end have the decimal point occurs somewhere in the middle of the zeros at the end? It doesn't really matter the location of the decimal point. What matters is the presence of a decimal point. So both of these zeros are significant. They occur at the end of the number. So this one is significant because this is not the point of least certainty. This is the point of least certainty. Okay, but we don't have any information past this point. So these are both significant figures. What about a number that looks like this? Okay, this number has all three kinds of zeros. It has the placeholders, which are not significant. It has a sandwich, and it has a number at the end, a zero at the end, and a decimal point way up here. Okay, again, these zeros at the end are not. Why? There's no decimal point. Okay, so remember, with your significant figures, you're looking for, if I ask you to take a couple of numbers and underline any digit in the number that would be considered significant for a measurement. Okay, let's look at these four numbers and ask ourselves which ones are considered significant. Anything that's not a zero automatically counts. So we can go through our numbers and underline all of the numbers that are not zeros. Those count. Now we'll go back and look at each of the zeros that we see and ask ourselves, where is it located? What kind of zero is it? Okay, this zero is at the end. So if the zero is at the end, we look for the presence of a decimal point. There's no decimal. So this one is a no. Okay, let's go to the next number over here. Okay, this 0 is in between the 4 and the 6. This is a sandwich 0. Sandwiches always count. This 0 is at the end. It's like this 0 here. It's at the end. No decimal point. This one is a no. Okay. Here, these zeros appear at the beginning of the number. They occur before the first non-zero digit. So these are all placeholders. None of them count. Okay, let's look at these zeros. These zeros occur at the end. Is there a decimal point present anywhere in the measurement? Yes, the decimal point here appears at the end. Doesn't matter the location of the decimal point. Again, it's the presence of a decimal point. So oddly enough, in science, this and this, mathematically, no difference. From a measurement standpoint of view, this gives different information versus this. This tells me that there is certainty here, no certainty here. The decimal point here says certainty and a little bit of uncertainty. Okay. It may seem like a pretty fine distinction, but it is really, really important when it comes to measurement. So now it's your turn to practice looking at different sets of numbers that are measurements. Just remember, in science, all numbers are measurements of some property, and determining, used with underlines, which numbers in the measurement would be considered significant.